We're going to learn more about magnets. So today we're going to read a book called Push and Pull, Learn About Magnets. Here's our table of contents. Remember, the table of contents can help us navigate our way through the book. A mysterious force. You can't see it, you can't hear it, but it has the power to push and pull. It's inside Earth. It's everywhere around your home. What is this mysterious force? It's the power of magnets. So if you look at this photograph, this is the force of the magnet holds these little screws tightly together to the magnet. Will it stick? You know that magnets stick to the fridge. Why? The door has a thin colored coating, but underneath there's metal. Magnets attract certain kinds of metal. Most often, magnets stick to iron. They can also pull on other magnets. So let's look at our photographs. We can see that nails have a lot of iron. Would they stick to magnets? Yes, they would. A pair of scissors, a thimble, and a needle would stick to magnets. The thread and the wooden spool would not. Pennies don't scoot to a magnet. Neither does gold. Paper and pencils stay put too. These things are not made of iron. They are not magnetic. Coins are the wrong type of metal for sticking to magnets. Pencils, papers, and things made of plastic do not stick to magnets. Magnets come in different sizes and shapes. Which one can pick up the most stuff? It may not be the biggest one. Even small magnets can grab things they're not touching. Hold a refrigerator magnet above a paperclip. You can make the paperclip jump. Magnets can be round. They can be rectangles or look like horseshoes. But what happens if you move the paperclip across the room? The trick doesn't work. Around each magnet is an invisible space. This space is called its magnetic field. A magnet works only inside its magnetic field. Scientists imagine a magnetic field as lines that loop from one end of a magnet to another. Try putting a piece of paper over a magnet. Then sprinkle the paper with small pieces of iron. The pieces will move into lines like these. So if you look at this illustration, it's showing how a magnetic field may look. Planet magnet. What's the biggest magnet on Earth? Well, it's Earth itself. You can see Earth's power. Dangle a small bar magnet on a string. It slowly turns. One end turns north. The other end points south. The magnet is attracted to Earth. You can use a compass to help you find your way. The compass needle is a magnet that always points north. The power of poles. A magnet's ends have special names. The one that is attracted to Earth's northern tip is called the North Pole. The other end is the South Pole. A magnet's power is strongest at its poles, but it works only in certain ways. So a magnet's poles are marked with N and S. Remember, the N is for the North Pole and the S is for the South Pole. Line up two bar magnets like train cars. Do the ends pull together? If so, you've matched the north and south poles. Opposite poles attract. What if the ends push apart? That means you've matched north with north or south with south. Poles that are alike repel. They push each other apart. So remember that repel means that they're going to push each other apart, and then attract means that they're going to come together. So the opposite poles on two magnets attract. These toy train cars are connected by magnets. If you turned the last car of this train around, it would not stick to the middle car. Magnets every day. Did you use a computer today? Did you talk on the phone? If so, you were using the power of magnets. Magnets are important parts of many machines. A telephone uses magnets to work. CD and DVD players use magnets too. Many magnets are electromagnets. Electricity makes them strong. A powerful electromagnet can pick up a car. What else can magnets do? Test it yourself with magnets. More magnet magic. The door of your refrigerator is probably coated with plastic, but you can still use a magnet to stick artwork on it, right? That's because magnets can work through certain materials. Here's a list of a few things that let the magnetic force through. So here's a list that glass, air, paper, cloth, plastic, and water are all items and things that you can still use to attract magnets because the magnetic force is able to get through them. So remember that we today are focusing on the word attract. Remember, the word attract means to pull together. And remember that the opposite poles on a magnet attract. And remember that repel means to push away. Poles that are similar or alike on a magnet repel.